Hello, so we're going to work on the Quiz 8 review on data analysis and statistics. So we are going to do, so for this one it says Jamal scored, so with his scores, they are already in order. It gives us a mean, median, and mode. So remember, mean is the average, median is going to be the middle number, and the mode is the most often. Mean, everybody is average. Okay, average, we add all the numbers together and divide by the number of numbers. So it asks us, so on his next quiz, Jamal got, let me write this first. In his next quiz, he got 91. Okay, and they ask us if anything's going to happen. So is the mean, median, and mode, are they going to increase, decrease, or is there no change? Sorry, increase, decrease, or no change. You can see over there. So we're going to calculate them. So I put the new one in. Let me look. So the median was 80. So that would be the middle number right here. So if we look at this 1, 2, 3, 4, 5, 6, 7. So there's 7 numbers with that 91. So it's still going to be, 90. Sorry, 91. Okay. So now there's 8 numbers, everybody. So those 2 middle numbers are still 80. So 80 plus 80, everybody, this is for the median. Remember our fraction bars, we have to add them first, or divide by 2. So that's still going to be 80. So there's no change for the median. For the mode, we're looking for the one that's the most, and there's no change for that one because it's still 80. Okay, now we need to calculate the mean. Okay, so we're gonna add them all together. So everybody add all of them together, all 8 of Jamal's scores. And divide by 8. Remember, everybody, please use the parentheses. We have to, so that we add it first before we divide by 8. Always, everybody, double check your numbers as you're entering them in. All right, so I got 80.5%. Everybody, this is for our mean, our mu. Okay, so it did increase. So the mean increased on that one. Okay. So our next one ask it is determine if equality is a parameter or a statistic. So this is, everybody, definitely look in your notes for this one. So a parameter are going to be boundaries for a population. Statistic measures describe a sample of a population. So a parameter, boundaries for a population. And statistic is a measure that describes a sample of a population. Everybody, for population, I'm going to use POP as my abbreviation. Okay, so average length of all the trout released into the river is 60 centimeters. Okay, so that is describing a population. Sorry, because it refers to a population. So that means it's going to be a parameter. Okay, next question says Westwood High School sophomore girls are a sample in a statistical study performed at the ACT testing committee. Which of the following is not a population of the study? So Westwood sophomore girls. Okay, so which one is not a possible one? So all the students in Westwood is possible. Sophomores who took the ACT, that's possible. All girls who took the ACT is possible. All girls in Arizona. Um, all girls who attended Carson, right? Because they are not sophomores, they are 7th and 8th graders. Okay, so that is one that would not include any sophomores. Okay, it says New Jersey randomly questions some of its high schools about attendance at a home football games. What attributes, at least two, are necessary to define the population in the study? Okay, so this is in New Jersey. This is a New Jersey study. Okay, so which ones are not going to work? That it's a junior high? No, because it said for high schools. It has a basketball team. Nope, that's not going to work, everybody, because we're talking about football. We are talking about football only. Yep, so we're only talking about football. It's a high school, that's possible. That it's in the U.S. School is in New Jersey, and school has a football team will work. Okay, any school in the U.S. won't work anybody because it could be a school in Arizona. And for New Jersey. So this is a survey of the New Jersey high schools. Okay, so in New Jersey. Okay, this one it says match each situation with the appropriate statistical study method. So experimental. We're going to apply treatments to a group and measure the effects. So the example that would work for that one is trying to determine if a new plant food actually works. So that fits for experimental. Observational studies are ones that measures or observes measures in a sample. So if we keep record of what kind of pets owners bring into the vet, that's an observation. And a simple survey, ask every participant the same question and record the answer. Asking people their opinions about local issues, that would be a simple survey or a sample survey. So we said sample survey. Okay, next one. It says, for the scenario below, which sample would be the least biased? A researcher is trying to decide whether or not people in her community enjoy work. She is evaluating what sample method would give the best and least biased results. Okay, so if they hand out surveys at a coffee shop, so that one is a convenience because you're just giving it to people who are right there. Choose members of the population nearby or easy to get to. And that one has biased, so that is a no. Okay, that one, high risk of bias because we're not choosing them randomly. Watch people as they enter the office and see if they're smiling. Okay, so that one also is actually a type of convenience one. Okay, so no, that would be biased. Ask local hiring professionals which companies are leaving. So that would be an example of stratified. I think stratified. Because we're dividing into groups with similar characteristics. We're asking the groups of local hiring professionals which companies are leaving. Okay. That one has the least amount of bias, but you have to take care to avoid bias on this one. Ask local companies if they have open positions. Okay, so that would also be volunteer, self-selected, and that could also have biased in that one. Okay, this one. So we're looking at this data, everybody. So we need to determine the shape of distribution, appropriate measures of center, and appropriate measures of spread. Okay. So remember, you can calculate them just like how we did on number 1. You can also go on the calculator, go to Stat, List 1, Edit, List 1, and put the numbers in. That's what I'm going to do. So I'm going to Stat, I'm going to enter the numbers in. You can also do where you go here, Stat, clear the list. Okay, so I like doing that before I do it, everybody, just so I put it in. I'd never just leave what somebody else put in because they could also have incorrectly put the numbers in, so always put them in yourself. Fine. Okay, and then we go back to here, go back to Stat, and calculate one variable, list 1. I press enter. Okay, so the shape. So for the shape, everybody, I go back here. For the shape, I go to y equals. Why should I do second? For plot, and we're going to graph it, plot 1. So I'm going to go second, stat plot, press enter for on. Type, we can do a box and whisker if we want. And then we go back here to zoom. Select box and whisker, and then we go here to zoom. We go down to number 9. For zoom stat, press enter, and it'll graph it for us. Okay, so that one is pretty much close to, it looks normal, okay? But we can also tell everybody if we look here, so go back to our stats. Okay, so our mean on this, everybody remember with this one, this is the mean. So it's 77.3. Our median, everybody, means median, is 77. Okay. So the shape is, everybody, it's pretty close. The mean and median are pretty close. We looked at the graph. So it's going to be normally distributed. If it's normally distributed, everybody, that means we use the mean. Okay, that also means that we use the standard deviation. Okay, so all these are connected. With a value of 77 and 3/10. And then our standard deviation, everybody, So 74.2, even though honestly that's the closest one to everybody, so that's looking at the population mean. Normally we were using this sample mean, standard deviation. Okay, this one, everybody, we're going to do the same thing. Okay, so I'm going to go back here to stat. Everybody, I'm going to clear the list. So you do second and the number 1 and clear it. So everybody, if I want to do it again, I go second, 2, clear it. And then it'll clear our list for us. So when I go back, the lists are clear. I was just doing all of them, they were in there. So I put all the numbers in. Okay, and then we go back here to stat. I'm going to go over here to calculate. Okay, so it gives us gives me a mean 26.6. Our standard deviation, just for using population 101. Our median is 29. So one way to look, everybody, is to notice that they're not close. Our quartile 1's at 21. Quartile 3 is at 33. We can also go second stat plot. Go back here and graph it. Everybody can definitely tell, look, the median is all the way over here. So this is definitely skewed. I always forget which way it's skewed. So it's skewed to the left. So this one, everybody, is skewed to the left. Okay. The median is greater than the mean. Okay, so that means we're going to use the median, which is 29. We're going to use the interquartile range. So remember, interquartile range, everybody, is quartile 3 minus quartile 1. So I go back here to my data values. Quartile 1 is 21. Quartile 3 is 33. So that's going to give us 12 for our interquartile range. Okay, next one. Oh, we're going to get work z-scores. Yay. Okay. So z-scores, everybody, z is equal to, it's going to be x, which is a data point, minus our mean, mu, and our sigma, our standard deviation. Okay, so we're going to go ahead and work on this. Mu is the mean, and sigma is our standard deviation. Okay, it says, okay, so Ella took the SAT test and scored 1,380. The SAT test had a mean of 1,000 and a standard deviation of 200. Okay, so for Ella, so if I'm doing the z-score for Ella, so that mean, this is our standard deviation, this is going to be our x value. So 1,380 minus 1,000 divided by 200 for Ella. So remember, you can also go alpha to do alpha x to get the fraction. So 1,380 minus 1,000. Scroll down, put in 200. If you get that, everybody, you can go math, decimal, enter, and it'll give you the decimal amount. So we get 1.9. Okay, so hers is 1.9 for her z-score. And then we need to figure that out for Alicia. So Alicia, it's going to be, her score was 29, mean of 21, and we're going to standard deviation of 5. Okay, so I put that in again. 29 minus 21 divided by 5. And I get 1.6. Okay, so that means that who performed better was Ella. She had the higher standard deviation of 1.9. Okay, so Ella is the one who performed better. She did better than the mean, right? She did better, 1.9 standard deviations above the mean, so she did better. Okay, a math teacher who looked at the normally distributed results on the recent quiz. The mean was 77%, and the standard deviation was 8. He decided to curve the grades based on the z-scores. If a z-score of 1.6 gets an A, what grade on the quiz is that? So that means that we're solving for our x value. So again, z-scores, everybody, is x minus the mean divided by our standard deviation. So I'm going to substitute them in. Okay, so we're going to multiply each side by 8. So get rid of our fraction. Okay, and now we can go ahead and subtract. If I can write. So I'm going to add 71 to each side. I'm going to get 83.8. So on the quiz, a score of 83.8%, everybody would be an A. Okay. Okay, everybody, you got this.